Ask my instructor 8.8.59. An investor deposits $15,000 into an account that pays 5% compounded continuously, and then begins to withdraw from the account continuously at a rate of $1,000 per year. Write a differential equation to describe the situation. How much will be left in the account after 3 years? When will the account be completely depleted? Let T be the time in years. Let A be the amount in the account in dollars. Let T be years. We're looking for dA dt, the rate of change of the account in dollars per year. With a 5% interest compounded continuously, the growth rate of the account is affected by the current amount in the account. Our change is that we are adding 5% of what we have. Also, we are losing a fixed amount of $1,000 per year. So, roughly speaking, dA dt, the change of dollars per year, is 5% of the amount minus $1,000. The reason why I said roughly is this is going on continuously, not in a discrete manner. So we have our differential equation and we're ready for the first question. How much will be left in the account after 3 years? What is the value of A at t equals 3? In order to find that, we have to solve our differential equation. First, divide both sides by 0.05a minus 1,000. And now integrate both sides with respect to t. Keep in mind that dA dt times dt is just dA. So integrating both sides with respect to t gives us this. Recall that we're looking for A of 3. I multiply the top by 0.05, and if I do that, I've got to compensate by having 1 over 0.05. And the reason why I'm doing that, I'm doing an informal substitution. I'm going to have U be 0.05a minus 1,000. And then du will be 0.05 dA. So I have written the integral so that it's in the form du over u. And I'm ready to integrate. All right, now what do we do next? Let's multiply both sides by 0.05. And now use the log rule. Couple of things I want to point out. I, technically speaking, would have e to the 0.05t plus c, which gives me a product, but e to the c is an unknown constant. We might as well call it c. So that's what happened there. Alright, keep in mind I'm trying to find A of 3, and so I keep trying to isolate A. Let's add 1,000 to both sides. And now divide both sides by 0.05. Now an arbitrary constant divided by 0.05 is still an arbitrary constant that we don't know. Again, we might as well rename it C. And this is what we have. Okay. At this point, we need to go back to the information in order to glean some sort of clue as to what C might be. We were told that the investor deposits $15,000. So at time 0, the account has $15,000. Put that information in. And I have 15,000 equals the function evaluated at 0. E to the 0 is just 1. Solve for C. And I get C equals negative 5,000. If C equals negative 5,000, I put that value in for C. And then I also do a little bit of arithmetic. That was a lot of work, but we're now ready to find A of 3. That's just a simple plug-in value. And we get about $14,000. So the account is being depleted faster. He started out with 15,000, and it is growing because of the interest, but money's being taken out as well. So after 3 years, he's got about 14,000. When will the account be completely depleted? We're looking for what value of t the function equals 0. So I set the function equal to 0 and solve for t. Subtract 20,000 from both sides. Divide both sides by negative 5,000. And now use the take the log of both sides and divide both sides by 0.05. And I get about 27.7 years. So A describes how much is in the account at any given time. We found that after 3 years he's gone from 15,000 down to 14,000, and we found that the account will be completely depleted in 27 years if the 5% compounded continuously remains and the taking out 1,000 per year continuously remains. All right, take care. Have a great day.